Hello, this is Charlene. In this video, we're going to talk about the fundamental counting principle. We're going to look at some ways that your textbook talks about the fundamental counting principle first. It says if you can choose one item from a group of m number of items and a second item from a group of n number of items, then the total number of two item choices is m times n. Another way they talk about the fundamental counting principle is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing occurs. So definitely this is going to involve multiplication. So we're going to keep that in mind. We're going to be multiplying the numbers of ways. Another way that they might talk about it is the fundamental counting principle is a rule used to determine the total number of possible outcomes in a situation. I need to also make you aware that the fundamental counting principle is also known by other names depending on the website you go to, depending on the textbook you go to. It can also be called the fundamental counting rule, the product rule, the multiplication rule, the rule of multiplication, and it's used in probability theory and combinatorics. But the simplest way that we can think about the fundamental counting principle is we can ask ourselves how many combinations are possible. We're talking about how to order a sandwich. Different people get different things in a sandwich. Some people might get different meats, different toppings, different vegetables. And so you would say, oh, how many combinations are possible? So the fundamental counting principle is at its simplest understanding is just how many combinations are possible. Our first problem says a car model comes in 9 colors with or without air conditioning, with or without a sunroof, with or without automatic transmission, and with or without anti-lock brakes. So the question that they want us to answer is, in how many ways can the car be ordered with regard to these options? Well, we have colors is one of our choices. So we have colors. We also have whether we have air conditioning or not, uh, option of a sunroof or not. Is it an automatic transmission or not automatic? Does it have anti-lock brakes? So all the choices that we have are color, AC, sunroof, automatic, and brakes. So we want to ask ourselves, how many choices do we have for each of these? For the choice of color, it says that we have 9 choices. So we have 9 choices for the color. So this is the number of ways or number of choices. So the number of choices. And what is our number of choices for AC? Well, it's either with or without AC, so we have 2 choices, with or without AC. Sunroof, with or without a sunroof, so we have 2 choices whether to have a sunroof or not. Automatic transmission or not automatic, so we have 2 choices there. And then with or without anti-lock brakes. So again, we have 2 choices, either with brakes, anti-lock brakes, or without anti-lock brakes. So these are all the number of choices. So remember, our rules say that we are going to multiply these. So we're going to do 9 times 2 times 2 times 2. That's a time sign. And times 2. And when we pull that up in our handy dandy calculator, we can do 9. Let's see, let's clear that out. 9 times 2 times 2 times 2 times 2. And that gives us a total combinations of 144. So in how many ways can the car be ordered with regard to these options? We have 144 ways or 144 combinations. Our next problem says you are taking a multiple choice test that has 8 questions. Each question has 3 choices. with one correct answer per question. If you select one of these three choices for each question and leave nothing blank, in how many ways can you answer the questions? So they want to know how many combinations. So let's think about this. We have a multiple choice test and we have 8 questions. So that means we have question 1, question 2, question 3, question 4, question 5, 6, 7, and 8. So we need to decide how many choices do we have for each one of these questions. So how many choices do I have for question 1? Well, I have 3, right? Because every single question, each of the questions has 3 choices. So I have 3 for question 1, 3 for question 2, 3 for question 3, et cetera, et cetera, et cetera. So we can think of this as being 3 choices for each one. And as we said before, we're going to be multiplying. We have 3 ways to choose an answer for question 1, 3 ways to choose an answer for question 2, etc. And so we are going to multiply all of these options. Now, if you remember from maybe one of your algebra classes, we can write this as a shortcut. Instead of putting 3 times 3 times 3 times 3, it's really like, say, like if we had x times x times x, you remember that that is x to the third power? Well, that's because I have 3 x's. Well, how many 3's do I have? I have 8 3's. So that means that I can shortcut this and I can say 3 by a factor of 8. I have 8 3's. So I can go over here and get my handy dandy calculator and put in a 3, and I can use the up caret and raise it to the power of 8 because I have 3 factors or 8 factors of 3, and that gives me an answer of 6,561. So that means that in how many ways can you answer the question? 6,561 ways that I can answer the question on this multiple choice test. Our next problem says that we have license plates in a particular state. They display 2 letters followed by 4 numbers, such as AT8875 or BB0130. So they want to know how many different license plates can be manufactured for this state. So we have to think of it in terms of what we have choices for. So we have choices for letters to be made. We have to choose letters and we have to choose numbers. So it says 2 letters. So that means 2 letters and 4 numbers. So we can think about it like this. I have 2 letters and then I have 4 numbers. So we have to think, how many letters do I get to choose from for the letters, the first 2 letters? So how many letters are in our alphabet? Well, there are 26 letters in our alphabet. So that means that the number of choices for the first letter are 26 letters to choose from. And the same thing is true for the second letter. We would also have 26 letters in our alphabet to choose from for the second letter. Well, how many numbers do we have? We have numbers starting with 0 and going all the way through 9, but that is actually equal to 10 different numbers. So it's 10 numbers that we have to choose from in our number system. So that's going to be 10 for that number. And then I get to choose from the same 0 through 9 and 0 through 9 and 0 through 9. And again, our rule says that we are going to multiply all of these choices times each other. So again, we need to think about it in terms of our shortcut. So if I've got 2 factors of 26, I can shortcut that and write that as 26 by a factor of 2, which is 26 to the second power. And I have 4 factors of 10, so I can shortcut that and say it's 10 raised to the 4th power because I have 4 factors of 10, and then I can multiply those two things. So let's go get our handy dandy calculator, and we're going to do 26 up caret to the 2nd power. I'm going to go out of that power and then do times 10 raised to the 4th power. And then that's going to give me a big old number. And this makes sense. We have a lot of cars in all of our states now. 100 years ago, we didn't have this many cars, but now we have a lot of cars. So according to this, we have 6,760,000 ways that we can have license plates or produce license plates. So 6,760,000 ways or different license plates that we can produce. 6 million different ways or different license plates. Different plates. Okay. So that is a lot of license plates, but it makes sense, right? Because we need a lot. Okay. Okay, the next problem says how many different 4-letter radio station call letters can be formed if the first letter must be W or K? So we're going to have a 4-letter radio station call letters like WIVK. So we've got 4 letters and we've got to decide what letters are going to go there. But it says that the first letter must be a W or a K. So this must be a W or a K. So we can think about this as W and K, but the others can be any letter, right? So I can have W or K, but this can be any letter, this can be any letter, and this can be any letter. But we still have to think, okay, how many things do I have to choose from for each of those letters? Okay, so the first one, WK, I only have 2 choices to choose from, W or K. But again, how many letters are in my alphabet? Well, there are 26 letters in the alphabet. And so that means I've got 26 letters to choose from for the second letter, for the third letter, and for the fourth letter. And again, we are going to multiply all of my numbers of choices together. So I'm going to pull up my handy dandy calculator. 2 times 26 times 26 times 26. And that is going to give me 35,152. So 35,152 different radio station call letters. So that is going to be the number of combinations of letters that I can come up with in order to give my radio station call letters. Okay, our next problem says telephone numbers in the United States begin with a 3-digit area code and it's followed by a 7-digit local telephone number. Area codes and telephone numbers cannot begin with a 0 or 1. So they want to know how many different telephone numbers are possible. How many combinations of telephone numbers are possible? So let's think about this. We've got an area code that is 3 digits, and then we have a 7-digit local number. So that's going to be 3 digits at the beginning, and then the last 4 digits. So we've got all these numbers that we have to fill in. But it says that the area code and the telephone number cannot begin with a 0 or 1. So that means this number right here, it cannot be a 0 or 1. Not. Okay, and then the beginning of the telephone number would be like right here. So this number also cannot be a 0 or a 1. But all of the rest of these can be any of our numbers. any of our numbers. So n, 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 and n, all stands for numbers. So what we can summarize that is that it's not 0 and 1, number, and then not 0 and 1, number, and number. Okay, so again, we always have to think of, well, how many choices do we actually have for each of these, right? Scoot that up a bit. So how many, if it's not 0 and 1, how many numbers do we normally have? We normally have 10 numbers, right? 10 numbers because it's 0 through 9. We can choose 0 through 9. So it's 10 for that number, 10 for that one, 10 for this one, and 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 this one. But these two right here, these two right here cannot be 0 and 1. So that means we have to take off 0 and 1, which means it reduces it to only 8 choices for those two positions. And of course, we are going to multiply all of these choices together. So 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10. And of course, we can shortcut it if we want. So how many factors of 10 do I have? I have 1, 2, and 3, 4, 5, 6, 7, 8. So I have 10 I have 8 factors of 10. And then how many eights do I have? I have an 8 right there and an 8 right there. So I have 8 by a factor of 2. So I have 2 eights and I have 8 tens. So that's how I can shortcut that. When I go to my handy dandy calculator and put it in my calculator, wow, that is a really big number. So how many different telephone numbers are possible? Well, let's put all of our commas in here. Let's see, let's raise that up just a little bit. So and comma, and comma. So that is 6,400,000,000 numbers for telephone numbers. Okay, 6,400,000,000 different telephone numbers. Okay, so that's a lot, and we need a lot because there's a lot of people in the United States, right? Okay. So I think this is the end of this video. So hopefully this helps you understand a little bit more about the fundamental counting principle and how to find how many total combinations are available to us in different scenarios. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.